Hello, everyone. Welcome back. And today we are going to be looking at the computer vision pipeline. The computer vision pipeline are the steps you need to carry out to develop a computer vision application. If you follow these steps accordingly, it streamlines the task of developing these solutions and it makes it easy for you. The first step in the computer vision pipeline is image acquisition. You need to get the images that you want to process. The next is image preprocessing. Sometimes when you get these images, they contain unwanted properties or they're in the format that you cannot work with. So you need to preprocess them to make sure that they are in the format that you want before going further. The next is image segmentation. You will need to divide this image into its various constituents. The next step is feature extraction. You need to extract features from this image to identify what is contained in the image. And the next step is feature recognition. In this instance, you need to recognize and understand the features that have been extracted. So let's look at these steps one after the other. Let's start with image acquisition. This is mostly the process of acquiring the image from a camera or a video feed. As you know, a video feed is a combination of multiple images arranged sequentially, and these images are called images are called frames. Now, in image acquisition, you need to acquire these images or image frames from the video so that you can process them further. This is usually done with a camera, but sometimes you might need to acquire the images, save them on a computer in a digital format, and later on when you want to process the images, you upload them into the computer vision application that you're working with. Now, when you collect these images at this stage, they're usually affected by noise and other unwanted features. And therefore, this means you need to pre-process the images further before you go to other applications. And this leads us into the next step, which is image pre-processing. In image pre-processing, you are mostly enhancing the image. Maybe it is blurry or it has faded out regions, and you're also removing unwanted properties such as noise. Now, there are many operations in image pre-processing. One of them is smoothing the image to remove the noise, and this is done using what we call filters. There are different types of filters. Some of them are 2D filters, two-dimensional filters, median filters, or Gaussian filters. Image preprocessing can also involve resizing the image. In some applications, you might need to put the image in a particular dimension for you to process it more efficiently. Particularly in deep learning applications, some deep learning architectures have specific dimensions of the image that you can feed in as an input. You might need to also generate a region of interest in an image. An example is you want to look at road defects. When you acquire the image of the road from a car, you would capture the skyline and buildings and trees by the side of the road. Now, the skyline and the trees and the sides of the road are not what you're mostly interested in. You're just interested in the road. And in that instance, you might need to crop out the other parts that you don't want so that the region of interest would only be the road. This leads to better computational complexity and faster performance. Sometimes you might need to adjust the contrast of the image, make it brighter or darker. In some applications, making the image brighter or darker highlights certain areas of the image that would make processing better. You can also enhance features by changing the color scheme. Maybe from a colored image, you convert it to grayscale, what we know commonly as black and white, or just highlight particularly colored areas in the image that you're interested in. An example is if you want to look at a traffic light. If you want to analyze the colors of a traffic light, then everything else is secondary to what you're trying to do. And in that instance, you can use color enhancement to only highlight the colors in the area of the traffic light. So in image preprocessing, you can do image sharpening. This is an image gotten from MathWorks, and you can see on the left what the image looks like before sharpening, and on the right what it looks like after sharpening. Mostly what sharpening does is highlights the pixels and everything becomes clearer. You can also do noise removal. In noise removal, on the left image, you can see it's affected by noise. This type of noise is called salt and pepper noise. And on the right is the image after the noise has been removed. You can also enhance the image. If it's blurry, you can make the image sharper. These images were gotten from MathWorks. In image segmentation, which is our next step, it involves you partitioning the image into different segments, dividing the image into different parts in a form that is easier to analyze. So examples of these segmentation techniques are edge detection. In this instance, you're only bringing out the edges in an image. And in that case, the edge, you're dividing the image into the parts that are the edges and the parts that are not the edges. And edge detection techniques, you have some of them here. Sobel is one of them, Kearney is another, and Roberts is another type. Kearney highlights more edges than the rest. It's more noisy, in quote, but Sobel and Roberts highlight the major edges in the image. It doesn't capture everything. So if you want a very sensitive application, you might need to go for Kearney, but if you want something that just highlights major features, then you can go for other ones. Then you can also do thresholding. Thresholding means you set in a value, and any pixel value above that becomes 1 or white, or any pixel value below that becomes 0 or black, or vice versa. In that instance, only areas of the image that meet that threshold requirement would be highlighted in the image. Then you can also do color-based segmentation, where you only bring out certain colors in the image. So we have some examples here. The first is an example of edge detection, and you can see what this means. This is Kearney edge detection, also gotten from MathWorks, and you would see that the segmented image only highlights the portions of the image, the edges of the image. Then you can see the color-based segmentation. The image on the left is the original image, but we're only interested in highlighting the red parts of the image. And you can see what color-based segmentation does. It only brings out the red aspects of the image. The next part of image processing and computer vision pipeline is the feature extraction. Now, here you identify the desired properties of an image. You look at these images and you see what are the unique desirable properties or features of that image, and you extract them. So there are various feature extraction techniques, and these include Hough transforms. Hough transforms helps you identify lines in an image. You can also use color-based detection to identify particular colors in an image. And also you can use the least square methods to extract features in an image or feature descriptors such as numbers. So this image just highlights, if you have a feature extraction algorithm, what are the various features that it looks like. So if you have an image of a motorcycle, the wheel is a feature, the handles are features, and so on. But in images, remember when we talked about pixels, we said that each pixel is a numerical value. So these features are usually numerical values. They are numbers that describe these features that you're looking at in an image. The final step of the pipeline is feature recognition. When you extract these features, you need to understand what these features mean. So you are verifying that the extracted features match a certain condition, or they are equal to a similar feature that you have and you are matching. So this feature recognition stage helps you identify whether, oh, it's a picture of a table, it's a picture of a ball, it's a picture of a chair, and so on. You need to match these features to identify what they mean. And this recognition can be achieved by comparing what you've detected, the features you've extracted, to a pre-stored value or something you've saved previously, and calculate certain parameters or variables. And if you look at this image, it's just an image of a vehicle and object detection. And you can see that the image processing algorithm or the computer vision algorithm is capable of detecting various things. This is the final stage after all the pre-processing, segmentation, and feature extraction. Recognition tells you, what have I extracted? So with the advent of artificial intelligence and machine learning, computer vision has mostly been integrated with these AI and ML techniques. So if you want to develop a computer vision application with artificial intelligence or machine learning, then the pipeline that we talked about earlier needs to be modified slightly to fit in with the incorporation of artificial intelligence. So the first step, of course, is still acquiring the image. You need to get the image from somewhere, either from a camera or from an image you've stored on your computer. And after that, you pre-process the image. So you remove the noise, you use filters and so on. Then after that, you segment the image. So edge detection, thresholding, color-based segmentation, and so on. And then you extract the features of the image. And when you extract the features of the image, you identify the relevant image features that you've extracted. And these relevant features should be features suitable to feed into the AI or machine learning model. So in this case, you might need to do some form of dimensionality reduction or just removing basic features that you would need to identify the image, and you feed them into a trained AI and ML model. So it is expected that this AI model that you are feeding the features into must have been trained using similar features from other images, so that the AI model will be capable of recognizing the images and the features of the images. And then this AI model will classify or predict or identify the image features based on what it has been trained on. And this can be done using supervised or unsupervised learning. You can use artificial neural networks and different AI techniques. And then the final stage is you're getting the output from the AI or ML model, which is usually a label or a class that tells you, okay, the image you fed in to the pipeline is an image of a ball, is an image of a cat, or an image of a house. So this is the computer vision pipeline, generally using artificial intelligence and machine learning. And in subsequent videos, we'll look at these steps of the pipeline individually and see the various techniques that you can use. Thank you.